All right. So I'm talking to you from my daughter's bedroom. My some of you might know her. Anyway, uh, as we get started here, we are going to be talking about today section 821, which is all about is the survey fair? Representative samples. So, whoa, go back to that one. Hold on. If you want to know about a bowl of soup, what a bowl of soup tastes like, do you need to eat all the soup in the bowl? Or can you get a good idea of the taste by trying a small sample? When you conduct a survey, it is not usually possible for you to survey every person in the population you're interested in, such as all female teenage shoppers or all of the students at your school. Instead, statisticians collect information about a sample, a portion of the population. However, finding a representative sample, a sample that represents the whole population well, is not easy. So today is kind of talking about how do we know what a good representative sample looks like. All right. So from last night's homework, I want you to pause as I go through these, kind of as I skim through this, pause it as you need and check your answers. 823 had a parallel box plot on the same number line, where this is distance from a bullseye. Part B, you should have said something like this. Neither set of data had any obvious outliers. The data for the right hand is symmetric with the median around 9. His left hand data was skewed towards the bullseye with a median around 3 inches. Lou consistently threw closer to the bullseye with his left hand. The interquartile range for his right hand is about 6. His left hand is about 4.5. So uh, he's definitely more consistent with that left hand, but he has a smaller interquartile range. So the variability of his data in his left hand was much smaller. It didn't vary very much. So that's why we could say he's more consistent. Part C, you should have said something like Lou throws more consistently with his left hand closer to the bullseye. And part D, the interquartile range should be 1. All right, moving on. 824, check your answer. And 825. 825 was an interest problem. And they asked you for the total in the account. So at the end of the problem, you have to add the interest to the original amount of money. Problem 826, I used cross multiplying to solve this problem just because it was easier than finding a giant 1 that makes 290 into 600. Ouch. And you should have x equal to 1034.48 meters. I did have to change the 4-minute 50 seconds into 290 seconds so that I have a single number here that I could work from to figure out 600 seconds. 827 looked like a 5D problem. And if X was Sherry's age, X plus 7 is Mark, X minus 11 is Eric, and together, when you combine them all up, you get 149 years. Solve that out. X, Sherry's age, is 51 years old, Mark is 58, and Eric is 40. Problem 28, I added 1 1/4 to both sides to get 3 3/4. On this problem, subtracted 2x and divided by 3, that's a divide by, to get x equal to 4. And on C, I just added 14.6 to both sides. Make sure you line up your decimals. Okay, now on to our lesson. 829, as the social director of a class council, Raman would like to survey a few students about their interest. When Raman analyzes the results from the survey, he wants to make claims about the interests of all of the students at his high school. If he were to survey only students on the class council, for example, it might be hard to make claims about what all students think. Students who are on the class council may not have the same social interests as other students. Consider this idea as you think about the samples below. A, if Raman wanted to generalize the opinions of all the students at a high school, would it make sense to go to the grocery store and survey the people there? Why or why not? I think that'd be a bad idea because uh, people at the grocery store that he surveys may not even go to his school. So the people at the grocery store who do not go to his school, not necessarily go to his school, is not a good sample. B, if he wanted to generalize the opinions of all the students at his school, would it make sense to ask all of his friends at the school? Well, this is better. These the kids, we know that these kids are at the school, but to generalize all of the students at his school, the people that are his friends might only be from his grade level, or maybe they're just a certain group. Maybe they're all the athletes or all the band members or something like that. So generalizing for all students might not be good if you're just picking your friends. So friends who have common interests, you know, the things that make us friends, who have common interests, may not represent the whole school, the entire school. Problem C. If he wanted to generalize the opinions of all the students at his school, would it make sense to ask every third person who entered the cafeteria at lunch? Well, that's definitely more random. It's definitely not people who have all of common interest, but it might only represent people who buy school lunch as opposed to people who bring their own. Maybe those people are different. So you can write your own answer for this one. I think it's a fairly good sample, but I think it could be better because the people who go in for lunch, maybe they're the ones who, maybe that's a different group of people. Maybe there's a bunch of people who go to clubs at lunch and don't go into the cafeteria, and you're missing those people. So I'm going to let you write your own answer for 29C. Problem 830. There are a variety of ways to choose samples of a population you're studying. Every sample has features that make it more or less representative of the larger population. For example, if you want to represent all the students at your school, but you survey all of the students at your school, but you survey all the students 30 minutes after the last class has ended, you're likely to get a disproportionate number of students who play school sports, attend after school activities, or go to after school tutoring. Part A. If you ask the opinion of people around you when you have used, then you have used a convenience sample. If you took a convenience sample right now, what would be some of the features of the sample? Would you expect a convenience sample to represent the entire student body? So if we were to take one in our class when everybody's there, because it's convenient, they're all right there, what would be some of the characteristics, the features of that sample? I think that we would basically get only seventh graders. So our sample would only be seventh graders and does not represent all of the students, of the student body. Depending on your class, you might have all the students who were, I don't know, depending on the school, maybe there's a whole bunch of people that are traveling from class to class to class together, and it might be all the kids that are in band all in one class. Who knows? So uh, that could be a problem. A convenient sample is not necessarily the best thing to do. All right. Part B, if you email or create an online questionnaire, then you've used a voluntary response sample. What are some features of the people in a volunteer response sample? Could it represent a sample of all the students at the school accurately? So in this case, we send a questionnaire out. The people who are going to answer that questionnaire and not ignore it are the people who care about the issue. So you might not be getting a very good sample because the people who don't care about the issue aren't going to answer the question because it's not a valuable use of their time. So what could we write here? What are some of the features? So in a voluntary response, um, you will often get people who care about an issue, who care about an issue enough to take time for the survey. Could it represent the sample of all the students in the school accurately? It could be representative, but it would have to be an issue that most students cared about. It could represent the school if the issue concerned most students. So that's kind of how a voluntary response sample works. The last example is called a cluster sample. You use a cluster sample if you first divide the students into smaller groups so that each smaller group represents all of the students at your school. Then you randomly select one or more of these groups to sample. How might you divide the students at your school into groups that each represent the whole school? And are there any reasons that these clusters might not fully represent the students at your school? Pardon me. So I suppose we could create groups of kids, like maybe if we were to take one 7th grade class, one 8th grade class, one 6th grade class, and then sample those kids, that would at least give us a section of 6th graders, 7th graders, 8th graders. We could also say we're only going to take students that are they're taking math, since everybody has to take math. So maybe we could do something like that. So how about if we say we could sample one group of 6th, 7th, and 8th grade math students, since everybody takes math. since all students take math. This would probably be a pretty good sample because we would end up asking all grade levels and randomly picking kind of a whole class at a time, but 1 of 6, 1 of 7, 1 of 8. So we're covering the grade levels. So that's a cluster sample. Problem 831. There's a resource page for this. If you want to print that out, you can pause right now. So now that you have the resource page, you can write directly on it. If you don't have the resource page, you can do this in your notebook. This is 831. You can kind of copy this down. It might take you a little while longer, but you can do it. From what population is each of these samples taken? Write down the actual population for each of these sample techniques. So, method of sampling. You call every 100th name in the phone book. Description of the actual population. So the people that are being surveyed would be people with phones who also have their numbers listed in the phone book. So you're not getting people who don't have phones. There are a lot of people who got rid of their phones and only have cell phones, let's say, that are not listed in a phone book. So now let's see here. If you survey people who come to the Vote Now booth at the high school football game. So in that case, you're getting, these are going to be people who care enough about, wow, I'm having a horrible time writing here, who care enough about the issue to stop at the booth. So these people really care. They're not going to walk by and go sit down with their nachos at the football game. You know what I'm saying? Next, if you ask every 10th student entering a high school football game, okay, that's a little bit better. You're asking pretty randomly, but you're only getting kids that seem to go to that like to go to sporting events. So you might only get a sample of people that support athletics. Okay, next one. Haphazardly survey students during a morning break. This is a good survey. This is a pretty good sample. This is a pretty good sample. It's relatively random. You might, the only comment I could have against that one is that maybe you're only getting people who are morning people, not the people who get up late, but I don't know. That's about that. The next one, you text a response to an online instant poll. Again, kind of like the one up here, you're only getting people who are interested in the poll. You only get people interested in the issue. That's one of those ones, that was the, if we look back here, that's a voluntary response. And so you kind of get people who really care about the issue checking it out. All right, the next one, you hand out surveys in a library before school. That's pretty random, but you're only getting people who go to the library. You might not be getting the guys that are out playing basketball before school. So your sample only includes people in the library. Yeah, you're not getting the people that are out on the yard hanging out with their friends. Last one, survey all students in period 1 English classes. This is a pretty good sample. Pretty random because every kid has to have English. Just because it's first period doesn't matter. So I would say this is a relatively random sample. It might represent your school fairly well since everybody's taking English. Okay, so that's what they mean when they say describe the actual population based on the method of sampling. It's hard to make a good sample. All right, 832. A study at the University of Iowa in 2008 concluded that children that play violent video games are more aggressive in real life. Children ages 9 to 12 were studied to determine how much they played violent video games. Peers and teachers were asked how much these students hit, kicked, and got into fights with other students. So let's see. They were checking out, they play violent video games. Are they more aggressive? Oh, interesting. All right. So part A, can you legitimately conclude from the study that teenagers who play violent video games tend to be more aggressive? Teenagers, children 9 to 12. These are not teenagers. So I would say no. The survey was not teenagers. If you ask teenagers the question, then maybe, yeah, that would definitely be better. Part B, can you legitimately conclude from this study that children ages 9 to 12 who play violent video games are more likely to commit violent crimes? I still think no. Now, they may find out from the data that that is true if that these kids hit and kick and got in fights more, but what if the people playing the violent video games were violent people already? Did the games make them violent, or did they were they already violent and then they liked playing the games? So um, I would say no on this. Uh, no, the let's see, the children playing the games may have been violent before the games. Part C, can you legitimately conclude from the study that children 9 to 12 who play violent video games tend to hit and kick more in school? Now, based on the previous one, they were looking to see if they commit violent crimes. In fact, I might even edit this. Children playing the games, they might not commit violent crimes, but these are not necessarily violent crimes. So here, can you legitimately conclude that children 9 to 12 who play violent video games tend to hit or kick more? You might be able to conclude this. Because it's the right age group, it's the correct age group, and type of violence. So they're asking about hitting and kicking in school, which is what they were asking about here. Part D, can you legitimately conclude from studying that playing a lot of violent video games will cause 9 to 12-year-olds to become more violent? No exclamation point. There might be an association, they might be connected, but the video games may not be the cause of the violent behavior. So you could say something like, they may be connected, meaning age and violence. They may be connected, not maybe, 2 words. Let's try that again. They may be connected, but not causal. C-A-U-S-A-L. So we're not saying that the game caused it. The kids may have already been violent prior to the games. So I would say it's not causal. Now you could do further studies after this, and maybe you could find that there is a cause involved, but this particular question and survey that they did will not necessarily prove that it caused it. And the last problem here. Addie was helping children in kindergarten class learn to read. She was curious how old the typical child was when they entered kindergarten. It was not practical to look up the school records for all 100 kindergartners. So, on the first day of school, Addie took a sample. She asked the parents of the first 15 students to be dropped off at the school how old in months their child was, how old in months. Her data is listed below. So one of the kids was 67 months, another kid was 61 months, 69 months, 72 months, and so on. Make an inference, a statistical prediction of the mean age of the kindergarten students. So if I took 67 plus 61 plus 69 plus 72 plus 71 plus 65 plus 67 plus 67 plus 57 plus 68 plus 71 plus 72 plus 61 plus 59 plus 62, and I divided it by the number of numbers, 15, because didn't she ask 15 people? Then I would end up with 969 divided by 15. When I bring up my calculator here, 969 divided by 15 equals, I get 64.6. Let me just double check my number here because that doesn't seem right. Oh, it's 989. I have my addition wrong. 989. Please fix that. All right, let's try that again. 989 divided by 15. I get 65.9-ish. So let's call this about 65.9 months. So that's the mean. Okay. Not an easy lesson. You might want to go back over it, read it again, look at some of the answers, and then try your homework. Your homework tonight is going to be to read the math notes and do 835 to 840. Always charge your Chromebook. Hopefully you're feeling well. Thank you for listening.